Hey, I'm Amy. Let's make some common sense out of limits in calculus. When you first start taking calculus, you'll see that the entire course is built upon the idea of limits. So it's a good idea to figure out what are limits. To me, the most basic explanation for a limit is where is the graph heading? So we'll take a look at some graphs in just a moment. First off, though, when we talk about a limit, we usually are referring to a two-sided limit, unless we have added extra information to signify that we're looking at a left-handed or right-handed limit. A two-sided limit, and this is the notation here for a two-sided limit, as x approaches some number a, some real number a, that limit exists if and only if the limit from the left, which is this guy here, notice the same number with a little minus sign, that limit from the left has to be equal to the limit from the right, and of course the limit from the right, we have a little plus sign to signify we're coming in from the right or from the positive side of the graph. So, limit two-sided exists if the limit from the left is equal to the limit from the right, and of course those two limits have to be the same numeric value, meaning they're not infinity, they're not undefined, they have to be an actual numeric value that we're approaching. Also, you might have noticed that I spelled if with two F's. That's not a typo. That is notation to imply that this is a biconditional relationship, meaning the two-sided limit exists if and only if the left and the right hand are equal to each other, and the left and right hand limits are equal to each other if and only if the two-sided limit exists. So let's take a look at the graph of y equals cosine x. So you'll notice I have the left-hand limit, the right-hand limit, and the limit from both sides notation here. Let's take a look at the limit as x approaches 0. Little minus sign means we're coming in from the left. So we're thinking about 0 and coming in from the left. So as the graph comes in from the left towards 0, the output values, the y values, are approaching 1. So we would say that the limit from the left as x approaches 0 is equal to 1. What about from the right? This is the limit as x approaches 0 with a little plus sign. Well, coming in from the right, it's heading to the same place. It's heading to 1. So in this case, we would say the limit from the right is equal to 1. Now, the limit from the left and the limit from the right are both equal to 1. Same value. It's a real number. Therefore, the limit from both sides is also equal to 1. Next, let's take a look at the graph of y equals tangent x. I've got limits from the left, limit from the right, and limit from both sides. And in each case, x is approaching pi over 2. And of course, as x approaches pi over 2 from either side, you'll see that we are approaching a vertical asymptote. Okay, so from the left, where is the graph heading? That's the real question to ask yourself. Well, from the left, as we get closer and closer to pi over 2, the graph is shooting up, up, up. Turns out the graph is unbounded, right? It keeps going up and up forever without ever touching that vertical asymptote. So in effect, you could say that the graph is approaching positive infinity. That's not actually a limit, right? You never get there. It's unbounded. It doesn't get capped. It doesn't have a limit. So officially, we would say that this limit does not exist. Likewise, coming in from the right-hand side, as we approach pi over 2 from the plus side, you'll see that the graph is heading down, down, down. It is unbounded in the negative direction. So we would say it's approaching negative infinity if you want to add that information, but you also would say that that limit officially does not exist. And of course, since the left and the right don't exist, then the limit from both sides cannot exist. And here we would just say does not exist.